Humans have always been fascinated by the night sky. Since our earliest ancestors first looked up, the twinkling stars have sparked curiosity and wonder. This endless expanse above us, filled with celestial objects, has driven us to seek answers. We yearn to understand our place in this vast cosmos. From simple observations of the sun and moon, we began to track their movements. These constellations were not just beautiful patterns, they became tools for navigation and storytelling. With each passing generation, our knowledge of the universe grew. As we delved deeper, we began to unravel the mysteries of the universe. From ancient civilizations to modern space exploration, the history of astronomy is a testament to humanity's unquenchable thirst for knowledge. The ancient Mesopotamians were among the first to systematically study the heavens. They meticulously recorded the movements of celestial bodies. They developed intricate calendars based on their observations of the sun and moon. These calendars were essential for agriculture, religious ceremonies, and daily life. The Mesopotamians were particularly interested in the planets, which they believed were gods or goddesses. They tracked their movements across the sky, noting their positions relative to the stars. They developed sophisticated mathematical models to predict future planetary positions. Their observations and calculations laid the groundwork for future astronomical discoveries. Their contributions to astronomy highlight the importance of observation, record-keeping, and mathematical analysis. Like the Mesopotamians, the ancient Egyptians were keen observers of the sky. They used their astronomical knowledge for practical purposes, such as developing a calendar and aligning their temples and pyramids. Their calendar, based on the cycles of the sun and the star Sirius, was remarkably accurate. It helped them predict the annual flooding of the Nile River, crucial for their agriculture. The Egyptians' fascination with astronomy went beyond practicality. They believed that the movements of celestial bodies influenced events on Earth. For example, the pyramids of Giza are aligned with remarkable precision to the cardinal directions and certain stars. This alignment suggests that the Egyptians possessed a sophisticated understanding of astronomy and its relationship to the Earth. The legacy of ancient Egyptian astronomy can still be seen today, not just in their monuments, but also in the constellations they identified. The ancient Greeks transitioned from mythology to a scientific approach in astronomy. Early philosophers like Thales of Miletus sought natural explanations for celestial phenomena. Thales predicted a solar eclipse, showcasing observation and reasoning. Pythagoras contributed to astronomy, proposing the Earth was a sphere. Aristarchus suggested a heliocentric model, with Earth revolving around the sun. Eratosthenes calculated Earth's circumference using geometry and sun's shadow. Section 5. Ptolemy's Universe, a Model for the Ages. Claudius Ptolemy, a Greco-Roman mathematician and astronomer, compiled and expanded upon centuries of Greek astronomical knowledge in his magnum opus, the Almagest. This comprehensive work presented a geocentric model of the universe, which placed the Earth at the center with the sun, moon, planets, and stars revolving around it. Ptolemy's model was based on meticulous observations and complex mathematical calculations. It accounted for the apparent motions of celestial bodies, including the retrograde motion of planets. Ptolemy explained it by proposing that planets moved in smaller circles, called epicycles, while orbiting Earth. The Ptolemaic model was widely accepted for over 1,400 years. While Ptolemy's geocentric model was eventually superseded by the heliocentric model, his work remained incredibly influential. The Almagest served as a foundational text for astronomers for centuries. Section 6. Stars Across Cultures, Islamic and Medieval Astronomy. During the Islamic Golden Age, which spanned from the 8th to the 13th centuries, astronomers made significant advancements in the field. They built upon the knowledge of the Greeks and made important observations and discoveries of their own. Islamic scholars translated and preserved ancient Greek astronomical texts, ensuring their survival and transmission to future generations. They established observatories, such as the one in Baghdad, equipped with sophisticated instruments for precise astronomical measurements. One notable figure was Al-Khwarizmi, a Persian mathematician and astronomer who developed algebra and trigonometry. Another prominent astronomer, Al-Battani, made highly accurate measurements of the Earth's axial tilt and the length of the solar year. During the European Middle Ages, astronomy continued to develop, albeit at a slower pace. The contributions of Islamic and medieval astronomers laid the groundwork for the scientific revolution that would transform our understanding of the universe. Section 7. Revolution in the Heavens. Copernicus, Brahe, and Kepler. The Renaissance marked a turning point in astronomy. Nicholas Copernicus, a Polish astronomer, challenged the geocentric view. In his book, De Revolutionibus, he proposed a heliocentric model, placing the sun at the center. Copernicus's model offered a simpler explanation for planetary movements. Tycho Brahe, a Danish astronomer, made precise observations. He compiled vast data on planets and stars. Johannes Kepler, Brahe's assistant, inherited this data. Kepler discovered planets move in elliptical orbits. He formulated 3 laws of planetary motion. Their work marked a paradigm shift in astronomy. Section 8. Through the looking glass, the telescope's impact. The invention of the telescope in the early 17th century revolutionized astronomy, allowing us to see farther and clearer than ever before. Galileo Galilei, an Italian astronomer and physicist, was among the first to use the telescope for astronomical observations. He made groundbreaking discoveries that challenged the prevailing Aristotelian view of the cosmos. Galileo observed craters and mountains on the moon, revealing that it was not a perfect celestial sphere as previously believed. He discovered 4 moons orbiting Jupiter, providing evidence for objects orbiting a celestial body other than Earth. Isaac Newton, an English physicist and mathematician, made significant contributions to astronomy as well. He developed the law of universal gravitation, which explained the force that holds the planets in orbit around the sun. The telescope, coupled with the laws of physics, transformed astronomy from a purely observational science to one grounded in mathematical and physical principles. Section 9. Expanding Horizons. Unveiling the Universe's Secrets. The 19th and 20th centuries witnessed remarkable advancements in astronomy, fueled by technological innovations and groundbreaking discoveries. William Herschel, a German-born British astronomer, discovered Uranus in 1781, expanding the known boundaries of our solar system. Henrietta Swan Leavitt, an American astronomer, made a groundbreaking discovery in the early 20th century. She observed a relationship between the luminosity and period of Cepheid variable stars. This discovery provided astronomers with a standard candle for measuring distances in space, enabling them to determine the distances to other galaxies. Edwin Hubble, an American astronomer, made one of the most profound discoveries of the 20th century. By observing distant galaxies, he found that they were moving away from us. This observation, known as Hubble's law, provided the first evidence that the universe was expanding, a cornerstone of modern cosmology. Section 10. From Earth to the Stars, the Space Age and Beyond. The mid-20th century marked the dawn of the space age, ushering in an era of unprecedented exploration and discovery. The launch of Sputnik 1, the first artificial satellite in 1957 by the Soviet Union, ignited a space race between the superpowers. Humanity ventured into space for the first time, with Yuri Gagarin becoming the first human in space in 1961. The Apollo missions, culminating in the first human landing on the moon in 1969, captivated the world and inspired generations of scientists and engineers. Space telescopes, such as the Hubble Space Telescope, have revolutionized our view of the cosmos, revealing distant galaxies, nebulae, and other celestial wonders in unprecedented detail. These missions have provided us with stunning images and invaluable data about our solar system and beyond. Section 11. Our Cosmic Legacy, the Ever-Evolving Quest. The history of astronomy is a testament to humanity's enduring curiosity and our relentless pursuit of knowledge about the universe we inhabit. From ancient stargazers to modern astronomers, each generation has built upon the discoveries of those who came before, pushing the boundaries of our understanding. Today, astronomy continues to captivate and inspire us. New telescopes, both on Earth and in space, are being built, promising to reveal even more about the cosmos. We are exploring the possibility of life beyond Earth, searching for exoplanets that could harbor life. The quest to unravel the mysteries of the universe continues, driven by the same sense of wonder that first led our ancestors to look up at the stars. As we delve deeper into the cosmos, we gain a greater appreciation for our place in the universe.